Hello friends, today I am going to deliver the lecture on the topic of reporting a crime. So in this game we have a group of n people, or can say group of n players who has observed a crime. Now here everyone like police to be informed about the crime, and at the same time they prefer that someone else make the phone call. Nobody want to take the risk. Here nobody want to take risk of phone call. So here if police get informed, then the value of amount V will be added to the payoff of each and every player if police get informed. Okay. Now if a person who is calling the police, he has to bear the cost C if he or she makes the phone call to the police, and here is a condition that she should be less than V and greater than 0. Now this game is a game of n people, and everyone is having two actions available, the call and the don't call, and every player is having a preference for taking an action which is based on the payoff function. So let's see the payoff function. So here in this slide I am calculating a payoff function for player I. So this is a payoff function for player I. So here we have three possibilities. The first possibility is that in which no one is calling the police. If no one is calling the police, means what? The police is not informed. If police is not informed, then we will not add the amount V in the payoff of any player. And nobody is calling, therefore nobody has to bear the cost of C. So the resultant payoff will be what? 0 only. Now the second case in which the player I is calling, the player I is the informer. So if player I is the informer, means what? The police is informed. The police is informed, then we need to add amount V to the payoff of every player, including I. So the player I will get the amount V in his payoff. Since he is the informer, so therefore we need to deduct amount C from the payoff. So resultant payoff is what? V minus C. Now we have third possibility, in that any other one person is calling a police other than I. Other than I, someone is calling police. I is not an informer in this case. I is not an informer. So means what? Someone else is calling, means what? The police is informed, right? So we will add V to the payoff of each and every player, including I. So the player I will also get V in his payoff. Since he is not an informer, the player I is not an informer, therefore we will not deduct amount C from the payoff. So total payoff will be V. Okay. Now in this game, we don't have any asymmetric pure Nash equilibrium. Asymmetric pure Nash equilibrium means the actions of player are different. The actions of players are different. So let's consider a scenario. In this case, the two players are calling and one player is not calling. Okay. So no, these two players are not calling. So therefore the payoff is these two players are calling. Therefore the payoff is V minus C, V minus C, and this player payoff is V because he is not calling. So we will not deduct amount C from the payoff. Now if this player change his strategy from calling to not calling, then previously his payoff is V minus C, and after changing his strategy he is getting payoff of V, which is greater than V minus C. Means what? A player can change his strategy, right? So we can say that in this game the no asymmetric pure Nash equilibrium exists. Okay. Similarly, here in this game, no symmetric pure Nash equilibrium exists. Symmetric pure Nash equilibrium means when the player strategy is same, all players are having same strategy. You can see that every player is having the same strategy of not calling, and everyone is getting the payoff of 0. Now if one player change his strategy from not calling to calling, then you can see after changing his strategy, he is getting the payoff of v minus c. Why is getting v minus c? Because he is calling. So means what? Police is informed. So we will add v to the payoff of every player. Since he is an informer, therefore we need to deduct minus c from the okay. But this v minus c is greater than 0. Previously the payoff is 0. Now his payoff is v minus c, which is greater than 0. Means what? This player can change his strategy. And we know in pure Nash equilibrium state, if any player changes his strategy, then we can say that such a strategy is not a pure Nash equilibrium. So this is not a pure Nash equilibrium. We consider one more scenario in which all players have chosen not calling. This is also not calling, this is also not calling, this is also not calling. Okay. So here the payoff of every player is 0. Sorry, we consider one more scenario in which every player is calling. Okay. Now the payoff of every player is v minus c. Why v minus c? Because the police is informed, therefore we have added v in the payoff of every player. Since every player is an informer, so we need to deduct minus c from the payoff of every player. Okay. Now if I assume that this player change his strategy from calling to not calling. Now if he is not an informer and somebody some other one is calling police, then the payoff will what be? Because he is not an informer, so we will not deduct amount c from the payoff. So this v is greater than v minus c. Means what? This player can change his strategy. So this is also not a pure Nash equilibrium, because we know that in pure Nash equilibrium no one can change his strategy. But here a player can change his strategy to get the better payoff. Now we all know that when in a game, when there is no pure Nash equilibrium exists, then we need to go for the mixed strategy. We know in the mixed strategy a player has to choose random action among the available actions which are having the same payoff, right? So in mixed strategy, player go for randomization between the actions. He chooses any action randomly when the payoff of the available actions is same. So in this game, for a mixed strategy, for any player, the payoff of call should be equal to payoff of don't call. Okay. So we will try to find out such a strategy when the payoff of call is not equal to payoff of don't call. So I am here in this slide. I am going to calculate the probability for a person for calling the police. Okay. So I am taking this condition first. The payoff of call should be equal to payoff of not call in case of mixed strategy. So here I am calculating the payoff for player I. This is a payoff for player I. Okay. Now if I assume that player I is an informer, then the payoff will be what? V minus C. Why V minus C? Because the police is informed by the informer I. So therefore we will add V in the payoff. Since he is informer, therefore we will deduct minus C. We will deduct the amount C from the payoff. Right. Now on the other side, we need to calculate the payoff of not calling. So payoff of not calling means the player I is not calling the police. Player I is not calling the police. So here we have two possibilities. The first possibility is that in which nobody is calling. When nobody is calling, so in this case the payoff will be 0 for player I, right? But we need to multiply with the probability for this possibility. So means the probability that no one call. Okay. Now what we have second possibility? The second possibility is that when the player I is not calling, but at least one person is calling, any other one person is calling other than I, but I is not an informer. So if any other one is calling, means what, the police is informed about the crime, so the player I will get V in his payoff. Since he is not an informer, therefore we will not deduct amount C from the payoff. Now we need to multiply with the probability that at least one person call the police. I is excluded. So here the probability for when at least one person is calling the police, but here I is excluded. Okay, because we already have fixed the action of the player I, which is not calling. Okay, now this whole term will become 0 because this is the 0. Okay, so we will get here V minus C equal to V into probability at least one person call I is excluded. Okay. Now we know that this term we can write like this. So probability of at least one person call can be write like 1 minus of so we can write this term as 1 minus probability that no one calling police, I is excluded because we are not including I in the players. Okay. Now we open the bracket and multiply V, so we will get V minus V into probability no one call police, I is excluded. So these two terms we will cut. Now we will get C by V equal to probability no one call police and I is excluded. Okay. Now I assume that P is a probability that a person call police. So P is a probability that a person call police. Now 1 minus P will be the probability that person not calling police. Now 1 minus p n minus 1 will be the probability that no one calling police except one player. So here this and this term is same, because this is the probability that no one is calling police except I, and this is the probability that no one calling police except one player. So we can write CYV is equal to 1 minus p power n minus 1, or we can write V is equal to 1 minus CYV power 1 upon n minus 1. So this is the probability with which a person will call a police. So if all persons call with this probability, then we can achieve the mixed strategy. At this probability value we can achieve the mixed strategy Nash equilibrium. So conclusion is what? So here P is the probability of calling a police is P, whose value lies between 0 and 1, and we have concluded that the game has a unique symmetric mixed strategy equilibrium. Why the unique symmetric mixed strategy? Symmetric because everyone is having the same probability of calling the police, and mixed is why? Because the player is randomly choosing the action calling and not calling. Okay, and the probability of choosing the action calling is 1 minus CYV power 1 upon n minus 1. So this is the solution of this game. Thank you.